was just a few years back.
This is 20 years ago.
All right, so we are ready to go here. We've got a very small but dedicated audience today, which is great. For those of you who don't know me, my name is Tony Gondola. I'm the outreach coordinator here at the museum, and I'm presenting today the new Road to the Moon. Now, before we can talk about the new Road to the Moon, we've got to kind of go back 50 years. It's actually 50 years next month, December, and take a quick look at how the old Road to the Moon actually ended.
Probably one of the most significant things we can think about when we think about Apollo is that it has opened for us being the world, a challenge of the future. The door is now cracked, but the promise of that future lies in the young people, not just in America, but the young people all over the world, learning to live and learning to work together. In order to remind all the peoples of the world, in so many countries throughout the world, that this is what we all are striving for in the future, Jack has picked up a very significant rock, typical of what we have here in the valley of Taurus Littrow. It's a rock composed of many fragments, of many sizes, and many shapes, probably from all parts of the moon, perhaps billions of years old. But a rock of all sizes and shapes, fragments of all sizes and shapes, and even colors that have grown together and become a cohesive rock, outlasting the nature of space, sort of living together in a very coherent, very peaceful manner. When we return this rock, or some of the others like it, to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future. A portion of a rock will be sent to a representative agency or museum in each of the countries represented by the young people in Houston today. And we hope that that rock and the students themselves will carry with them our good wishes, not only for the new year coming up, but also for themselves, their countries, and all mankind in the future. To commemorate not just Apollo 17's visit to the valley of Taurus Littrow, but as an everlasting commemoration of what the real meaning of Apollo is to the world, we'd like to uncover a plaque that has been on the leg of our spacecraft that we have climbed down many times over the last 3 days. And I'll read what that plaque says to you. First of all, it has a picture of the world, two pictures, one of the North America and one of South America. The other covers the other half of the world, including Africa, Asia, Europe, Australia, covers the North Pole and the South Pole. In between these two hemispheres, we have a pictorial view of the moon, a pictorial view of where all the Apollo landings have been made, so that when this plaque is seen again by others who come, they will know where it all started. The words are, "Here man completed his first exploration of the moon, December 1972 AD. May the spirit of peace in which we came be reflected in the lives of all mankind." It's signed Eugene A. Cernan, Ronald E. Evans, Harrison H. Schmidt, and most prominently, Richard M. Nixon, President of the United States of America. This is our commemoration that will be here until someone like us, till some of you who are out there who are the promise of the future, come back to read it again and to further the exploration and the meaning of Apollo. Port stage pushed. Engine arm is destined. Okay, I'm going to get to pro. 99, proceeded. 3, 2, 1. Ignition. Right away, Houston. Regs are good. Ag thought. Pitch over.
Roger, you have good thrust.
So I think it's interesting to give you that background and get an idea of what their thoughts and hopes were way back in 1972. And when they were talking about young people being the promise of the future, well, those young people are my age now. So it took a little bit longer than I think Gene Cernan had actually thought it was going to take. But finally, it is happening, and that's what we're going to take a look at today. Now, when they lifted off from the moon on Apollo 17, December of 1972, that was the end of the moonwalking part of the Apollo program, but it wasn't the definite end of the program, because there was always a part of Apollo called Apollo Applications, and the idea of Apollo Applications is that once the moonwalks ended, they take the Apollo technology and use it for other purposes in low Earth orbit and some other things. And so they had a lot of ideas about what that was going to look like. They were definitely looking at the idea of a lunar base. They were looking at different variations of the lunar module as a taxi or actually as a shelter that they could land on the surface. They even had a multi-purpose surface-to-surface flying vehicle. So instead of using a rover, they could actually fly from one spot to the other, which I think was a great idea. And also, you know, they're looking at a manned flyby of Venus and, of course, a space station in Earth orbit. So there are a lot of things that were behind that. Now, we did actually come to fruition on some of these ideas because we did get Skylab launched in 1973 and re-entered in 1979. And I believe, Chris, correct me if I'm wrong, Skylab was the actual last launch of a full-up Saturn V. Is that right?
Yes.
Yeah. So that was the last time we used that rocket. This was the last payload. And in 1975, we had the Apollo-Soyuz test project. Now on Skylab, of course, the idea of the space station was part of Apollo applications, but more specifically, the Apollo telescope mount, which is right up at the top there, and was used extensively during the 3 Skylab missions, was right out of applications. And for the Apollo-Soyuz test project, they had to have a very special docking adapter because the Soviet docking system and the American docking system were completely different. The 2 spacecraft used different mixtures of gases, and I believe they were also at different pressures. So they had to have a sort of a common vestibule where they could take care of all of those things and make it work. But that was really the last of Apollo applications. The Apollo program truly ended on July 10th, 1979, when Skylab had an uncontrolled re-entry over Australia. And I remember that day, it was on the news, and people were really freaked out because nobody knew exactly where it was going to land. And actually, they thought for a while that it was going to land somewhere in Maine. And I was working at Massachusetts at that time, and I could actually see pieces coming over. They hadn't re-entered yet, but it was pretty interesting. So anyway, that 1979, that really was the end of the Apollo era. Followed by what I would call the low Earth orbit era, which was involving the space shuttle and also, of course, involving the space station. And there's a really strong synergy between these two things because a large part of why the space shuttle was developed was to build the ISS. And you really couldn't have built the ISS as it is today without the capability of something like a shuttle bringing up those payloads constantly. So the shuttle really was the workhorse of low Earth orbit. And it did a lot of other things. One of the most important things to me was the repair of the Hubble Space Telescope. Because Hubble was launched with miscorrected optics to begin with, so they had to have a crew go up there and actually make the fix on that. But they also visited Hubble later to make other corrections and replace equipment that had gone down. And that's really the reason why we even have Hubble still operating today, is because of the servicing missions by the space shuttle. And the altitude of Hubble is actually higher than space station. Space station is about 250 miles above the surface. Hubble is about, Jim, 360, 360?
It was 360, but now it's down to 330.
Right, because of the decay. So, and that was right at the limit to where the shuttle could go. It really couldn't go much higher than that. And if you did, you're going to have some problems with radiation from the Van Allen belt. So, but it was pretty amazing that they were able to do all that stuff. Did a lot of scientific research and what have you. So we're here to talk about tonight NASA's new Saturn class launch vehicle, and I'm saying new in quotes, and you'll see why in a little bit. They don't have a great name for it, like Gemini or Mercury or Apollo. They're just calling it Space Launch System, SLS for short. So when I'm talking about SLS, I am talking about this heavy lift launch vehicle that you see here. Now we kind of look at this in detail. What does this rocket remind you of? Just looking at it. Does it remind you a little bit of the space shuttle? And that's because it's actually reusing some shuttle components, and it's using modified versions of other components. Okay, the 4 RS-25 liquid fuel engines, all of those engines that are on SLS right now have previously flown on space shuttle missions. Some a lot, some less than the others, but those are actually used engines. The solid rocket boosters on either side, they're basically shuttle-era solid rocket boosters. They're just extended by one segment. So instead of being made of 4 segments, they're made of 5 segments. So they get a little bit more burn time out of that. And the core stage, the large orange tank in the middle, that's where the fuel is stored. And it's basically an extended shuttle fuel tank. Everything from the extended tank up is new. We've got the crew module, service module, launch escape system, and all of that. And actually Orion, the spacecraft, has flown before. I believe that was in 2014 when that test flight for Orion was very successful. So the Orion spacecraft is already proven in space. It hasn't taken a manned crew up yet, but it looks to be a really good piece of equipment. So that's how SLS was created and put together. The other note that I'll make about SLS, they saved a lot of money by not having to reinvent the wheel and invent new technology, just extend technology that they already have. And you'll see later that that's resulted in a very much lowered cost to manufacture the vehicle. But none of this is reusable. So that's going to affect the actual cost to launch. And there are different versions of SLS that are planned. What we're looking at right now, as a matter of fact, it left the VAB building last night at about 12 o'clock Eastern, and it should be on the pad now as we speak. Made that trip out there, hopefully its last trip out there. So the rocket that we're looking at right now is Block 1. That's going to be followed by Block 1B, which is the crewed version of the Block 1 spacecraft. There's also a cargo version of the Block 1B. So there's 3 versions of that, and eventually they're going to upgrade to the Block 2, which has more thrust, more capacity, and again, there's going to be a crewed version of Block 2 and a cargo version of Block 2. But Block 2 is capable of sending 45 tons on a lunar trajectory. So it's very, very capable. It's definitely a Saturn-class vehicle. I'm going to go ahead and look at another video here. We're going to take a close look, brought to you by Lockheed Martin, of the actual Orion vehicle itself.
When most people think of human spaceflight, they think of it here. And maybe that's because right now, it's as far as they can go. When I think of space, I think of it here, or even farther, millions of miles farther than anyone else, into the black void of deep space. Only I can take you out here, because I am one of a kind. To sustain life out here means overcoming immense challenges. The conditions are inhospitable, with the most extreme temperatures, distances, and velocities. The dangers are immense. I am the only spacecraft that can carry our most precious cargo, humans, out into deep space. I am in a class all of my own. Exploration class. I am Orion. I am here to expand our capabilities, increase our potential, and open the doors to new possibilities. I am a culmination of so many of the brightest minds from across the world who designed, 3D printed, welded, wired, coded, fastened, machined, and assembled me to carry humankind through the depths of space to new frontiers. I am created from a million dreams willing the impossible into existence, giving way for us to unearth new discoveries from extraterrestrial soil, pushing technology ever forward in the service of our life here on Earth, extending humanity's reach to walk on new worlds, taking us farther than we've ever gone before. I am a single vessel traveling out here, but I am hundreds upon hundreds of technological challenges solved. I carry 4 astronauts inside me, but I also carry part of every one of the thousands of engineers, technicians, scientists, and dreamers who brought me to life. An amazing amount of ingenuity, collaboration, and expertise is what makes my mission possible. I carry more than 60 years of innovation in space exploration and a countless amount of engineering passion, all the way out here. I am Orion.
So there you have it, the Orion spacecraft. I do think it's a very capable video. Maybe not quite as capable as they're advertising there, but very capable nevertheless. So it's really interesting because you probably noticed that the Orion spacecraft looks a lot like the Apollo command module. And the reason for that basically is the Apollo guys got a lot of things right. Physics haven't changed, and if you have an ideal shape for something, an ideal way to approach things, you're just going to reuse those ideas, and that helped a lot with Orion development. However, it is a larger spacecraft. Nominal crew size is going to be 4 astronauts, although it can take a total of 6 up and down from the ISS if they ever do those kinds of missions. And it is completely new technology. We've never really flown a heat shield formed the way this heat shield is formed. And it's also highly computerized. You get into an Apollo command module, and it's like getting into the flight deck of a Boeing 707. It's a lot of switches and dials and gauges, and it's very, very analog. But the Orion spacecraft is very much computerized. We're using a lot of flat screens and those kinds of things. So it's a much cleaner, much more modern look on the inside. And again, it is very capable. So let's take a look at the differences between the Saturn V, the old moon rocket, and the new SLS. Now, SLS, a little bit shorter, at least Block 1 at 322 feet versus 363 feet. It's a little bit lighter. It comes in at 5.5 million pounds on the pad versus 6.2 for the old Saturn V. It also produces more total thrust. It produces 8.8 million pounds of thrust at liftoff versus 7.6 for the Saturn V launch vehicle. Top speed, I think they made a little bit of a mistake here because it's the same for both. It's 24,500 miles an hour, which is the speed that you attain right after TLI, translunar injection. That's also the speed that you have right at reentry, and that's going to be the same for both. The cost to build, and this is kind of interesting because I'm going to give it to you in 2022 dollars. So the SLS costs $23 billion. The Saturn V, if you could build one today, estimated about $51.8 billion. And part of the reason for that difference in price is with the Saturn V, they were designing everything pretty much from the ground up. It was all new technology, whereas the SLS, and this is where they benefit, by reusing actual shuttle hardware and shuttle ideas. So that cuts the cost down quite a bit. But when you look at price per launch, it goes the other way. $1.49 billion to launch a Saturn V in today's dollars, $4.1 billion to launch an SLS in today's dollars. And I'm not quite sure where that big difference in price comes from, but it is definitely there. And it's one of the problems that the program is going to face because they have to get continued funding in order to pay for these launches. And Jim, I don't know, do you have an idea about why there's such a big gap there?
All I know is that the costs for SLS, you can't figure them out to save your life.
Yeah.
And it does have, the way that they calculated that had to do with the amortized of how many launches they had and how many they're expecting at the current time with SLS and all the test launches of the Apollo compared to the SLS.
That's true, because the more vehicles you make, the more you launch, then the price goes down per launch, and that makes sense. So I think right now they're looking at one SLS launch a year, pretty much.
Yeah.
So
right
not
now,
very
for the
frequent.
next 3.
Yeah, we were flying Apollo a lot more frequently than that. Okay, so let's take a look, because the mission that's going to be flown, by the way, it's before I forget to tell you, it's on the pad right now. It's going to launch, slated to launch on the 14th of this month, a little bit after midnight Eastern Standard Time. So it's going to be a really spectacular night launch reminiscent of Apollo 17. So it should be really, really something to see. And the SLS has a higher...
Just so people don't get confused.
Yes.
For us, the launch is November 13th,
At 10
just
o'clock.
after 10 o'clock.
That's right.
Just so that you're not thinking, oh, it's on the 14th.
That's right. That's why I said Eastern Standard.
For us, it's
Yes.
November 13th, just after 10 o'clock at night.
Absolutely right. So this is an uncrewed mission, okay, but it is a full-up test of everything. And this is basically what it's going to look like.
In the next 8 minutes, you'll experience a 25.5-day mission from rollout to recovery. The first integrated flight test of the Orion spacecraft and the Space Launch System rocket launching from the Kennedy Space Center is about to unfold. This is the first of many missions to come that will use the Deep Space Exploration System to prepare our team, our ship, and our astronauts for human operations in deep space. Rollout from the Vehicle Assembly Building signals that launch is near. Sitting atop the mobile launcher, the crawler transporter moves along the crawlerway towards historic Launch Pad 39B at the Kennedy Space Center at a top speed of 1 mile an hour. After traveling over 4 miles, the rocket and the spacecraft climb up a ramp and are positioned over a flame trench. Once in position, the mobile launcher is lowered onto support post and the crawler is rolled away to a safe distance. Final checks are performed at the pad, including crew cabin closeout via the access arm sitting over 300 feet above the surface of the launch pad. The launch date is set, and the teams are prepared for the mission that is about to occur. It's sunrise on launch day. Engineers in the Launch Control Center have already powered up the spacecraft and the rocket and loaded the core stage and upper stage with cryogenic fuel. As launch window open approaches, final checks are performed, and when all systems are go, terminal countdown is initiated. The big physics of launch are about to be put on full demonstration. Umbilical plates weighing hundreds of pounds await their cue to retract to clear the path of the rocket at liftoff, some mounted on arms the size of tractor trailers. The mighty core stage engines are prepared for engine start as they are thermally conditioned for an onrush of cryogenic fuel in the heat of ignition. At T-minus 15 seconds, sound suppression is activated, cascading water into the flame trench to dampen the acoustic shock. And as the core stage engines achieve full throttle, shock diamonds appear. At booster ignition, the flame trench is flooded with fire. At first motion, all umbilical arms are retracted and the rocket clears the tower in just seconds. At liftoff, the vehicle produces 8.8 million pounds of thrust and lofts the vehicle weighing nearly 6 million pounds and standing 32 stories tall to orbit. Propelled by a pair of 5-segment boosters and 4 liquid engines, the rocket achieves maximum dynamic pressure only 90 seconds into the mission, the period of greatest atmospheric force on the structure of the rocket. Thousands will gather in Florida to watch our ship get smaller and smaller and leave the Space Coast behind. Approximately 2 minutes into the mission, the boosters will have consumed all of their solid propellant and are safely jettisoned. The rocket will continue on, guiding itself to orbit with magnificent precision. Just 3 minutes into the mission, the service module fairings are jettisoned to lighten the vehicle and expose Orion's solar arrays. Just 40 seconds later, the launch abort system is also jettisoned. It is no longer needed. Orion could safely abort at any time. Once at the desired velocity target, the core stage engines are shut down and the core stage separates. The interim cryo-propulsion stage with Orion will continue to orbit the Earth. Along the way, they will pass through the altitude of the International Space Station at 250 statute miles. During this first orbit, the solar arrays are deployed so that Orion no longer needs battery power. It can now produce its own power. Following solar array deployment, the arrays are positioned into a load-bearing configuration to prepare for the perigee raise maneuver. The raise maneuver will ensure an Earth orbit and use the thrust provided by the interim cryo-propulsion stage. Once the perigee raise maneuver is complete, Orion systems are checked prior to committing to the translunar injection, or TLI maneuver. The TLI maneuver must be successfully completed to depart Earth orbit. The TLI burn is approximately 20 minutes in duration and increases the spacecraft's velocity over 9,000 feet per second, a speed change faster than a high-powered rifle bullet travels. Following TLI, Orion is committed to a lunar trajectory, just 1.5 hours after launch. Once complete, the spacecraft adapter will remain with the interim cryo-propulsion stage, and they will separate from Orion. As Orion departs low Earth orbit, it will fly through the orbital debris field encircling the Earth, past the global positioning navigation satellites, past the communication satellites in geostationary orbit, and through the Van Allen radiation belts, on into the deep space radiation environment. Orion is now entering an outbound coast phase. The spacecraft is uniquely designed to navigate, communicate, and operate in this deep space environment. The outbound coast to the Moon will take approximately 4 days. As Orion approaches the Moon, the service module will be used to perform a critical lunar gravity assist maneuver, allowing the ship to enter a distant retrograde orbit about the Moon. The Moon will get larger and larger in the window, and at closest approach, Orion will be just 62 miles from the surface of the Moon. As the spacecraft flies around the far side of the Moon, we will lose all communication back on Earth, and for a period of time, Orion will be on its own. Mission Control will await acquisition of signal, and as we lock on, a new generation will see their first Earthrise. The spacecraft is now in the distant retrograde orbit, where its systems will be tested in the deep space environment for over a week. Along the way, our ship will travel farther from Earth than any human-capable spacecraft has ever gone. At the farthest point, Orion will be some 1,000 times farther from Earth than the International Space Station, at over 270,000 miles away. Teams in Mission Control Houston and at Naval Base San Diego will prepare for Orion's return home, and the recovery ship will set sail for the recovery zone in the Pacific Ocean. Orion will exit the distant retrograde orbit with another lunar gravity assist and service module engine firing. Along the way, the trajectory will be adjusted to target the Earth's thin atmosphere at over 250,000 miles away and ensure a precision landing in the Pacific Ocean following a direct entry. During the coast home, Orion will maintain the desired tail-to-sun attitude to optimize spacecraft cooling and maximize power production in the deep space environment. Another 4 days return coast home to Earth. As our home planet fills the windows of Orion, an important contribution from our European partners called the service module has done its job. The service module is jettisoned and separates. Following separation, the world's largest heat shield will be oriented into the direction of travel to prepare for entry interface at an altitude of 400,000 feet. At entry interface, Orion will hit the Earth's atmosphere traveling at a speed of 24,500 miles an hour and decelerate at up to 9 times the force of gravity. The heat shield will protect the spacecraft from temperatures half as hot as the surface of the Sun, approaching 5,000 degrees Fahrenheit. Orion will continue to decelerate, pass through the sound barrier, and announce its arrival to the waiting recovery team with a sonic boom. Following peak heating, a protective thermal cover that sits over the parachutes will be jettisoned. This begins a series of parachute deployments. The drogue chute deployment series is designed to stabilize and slow the spacecraft, and in a period of less than 20 minutes, Orion will slow from a speed of Mach 32 to 0 at splashdown. The 3 main parachutes will deploy and slowly unfurl and suspend the 22,000-pound capsule and allow it to gently descend to the surface of the ocean. After 25.5 days, and a total distance traveled exceeding 1.3 million miles, a precision landing within eyesight of the recovery ship. Following splashdown, Orion will remain powered for a period of time as Navy divers approach in small boats from the waiting recovery ship. After a brief inspection for hazards, the divers will hook up tending lines and a tow line. The capsule will be then towed into the well deck of the recovery ship, and once the capsule clears the stern gate, the gate will be closed, the well deck will be drained, and we will bring our ship home. We invite you to follow along at www.nasa.gov/exploration.
So as you can see, the upcoming test flight is going to be a pretty interesting one. I think it's very ambitious, and it's really going to be a very thorough checkout, proving the SLS launch system, but really proving the Orion spacecraft and service module combination for quite a while in deep space, as they said, further than we've ever gone as far as these types of missions are concerned. I hope you notice how quickly it got off the pad, too. You know, the old Saturn V, you'd watch it and it would just it wouldn't lift off, it would ooze off, right? It took a long time just to clear the tower. But this guy gets up and going a lot faster. So that's pretty interesting. More like a space shuttle than a Saturn V.
What's the fuel to get that rocket?
Well, we got the solid rocket boosters, so it's a combination of the solid fuel from the boosters, and they actually contribute most of the thrust. But they also, the 4 main engines use liquid hydrogen and liquid oxygen, just like the space shuttle did. So it's a combination of fuels. So that's what we're expecting on Artemis 1. Artemis 2 is actually going to be the first crewed mission of the SLS system. And they're going to be taking a crew all the way out to the moon, loop around on something similar to a free return trajectory. They're not going to be going into orbit and then coming right back. And that'll be a thorough checkout again of Orion and its crew support systems and all that good stuff. They need to really do that before they can feel confident in a landing mission. And the landing mission is actually slated to happen on the 3rd flight of Artemis, Artemis 3. And this looks a lot more complicated than what we did during Apollo. And that's because it truly is. Because you'll notice this orbit that goes north to south, that long elliptical orbit there. That's supposed to be the orbit for the a little station. Okay, what do they call that, Chris? What's that called?
I'm sorry, what's that?
The station that they're going to put in orbit around the moon.
Gateway.
Gateway. That could be, yeah, that's Gateway. Gateway. And the idea is the Gateway has this long orbit, so it spends most of its time away from the moon, and then once in its orbit, it gets real close, and that's when you want to detach for landing, or you want to join the station to bring it back. So that's why it's there. It's more fuel efficient, actually, for the crew to do it this way, and it gives them a lot more flexibility. You'll also notice that it's a polar orbit. And polar orbits are really great because from a polar orbit, you can essentially land anywhere on the surface. But what they're really interested in are the poles of the moon, particularly the south pole of the moon. And we'll talk a little bit about that later. Now, you might notice that it's a little strange that I haven't really talked about a lander yet. Because unlike Apollo, which was one launch, everything was in the rocket that they needed, there isn't a lander aboard SLS. Now, they did have a contest amongst a number of companies to propose ideas for what the lunar lander would be, to find a contractor. They ended up going with SpaceX. And there's going to be, at least at this point in time, there's going to be a lunar landing variant of the SpaceX Starship. which is designed just to do this one thing. And this is a surprise to a lot of people. It was a real big surprise to me, because to my eye, it doesn't really fit the system, but that's what they're going with. So they're just going to have to figure out how to get the astronauts from way up there to way down there. So they're going to have some sort of external elevator system or whatever.
Rope ladder.
Well, I'm sure as a backup, they probably will have a rope ladder, or But it's pretty interesting. So yeah, well, there's no air, so that's not going to help. You're just going to drop in the stone. I'm lucky I'm not the guy that has to prove that, but yeah. Well, you will drop in 1/6 gravity, but it's a long drop. So this is how it's actually going to work. The first thing that's going to happen is that they're going to launch a SpaceX Starship into low Earth orbit. Now, the thing about Starship, it is completely expended of fuel by the time it gets to orbit. It takes that big booster and all of the fuel in Starship just to get to low Earth orbit. So when it gets up there, it's going to be essentially empty. So that's going to require 4 more launches of Starship, just carrying fuel. And they will refuel Starship in low Earth orbit until it's ready to go to the moon. Then it will make its way out to the Gateway. At that point, the Orion with crew will launch. And they will meet up with the Gateway and their landing vehicle, and they'll transfer to the landing vehicle. They'll use the Starship to come down to the surface and also to leave the surface, come back to the Gateway, and then the crew will return. So there's a lot of things here that can go wrong. It's a very complicated way of doing it, which is part of my surprise that they actually decided that this was going to be the format. But as of today, this is what they're planning to do. The other thing that's odd about it, if you have a fully refueled Starship, why do you need SLS? I'm not really sure about that. But I'm sure there are smarter people than I am that have thought about this, and it makes sense. At least I hope so. So you may ask yourself, why do we have to go back to the moon, right? Everybody's talking about Mars, and why go back to the moon? Apollo returned over 800 pounds of lunar samples that we're still studying. Some of those samples are still in storage. They haven't even been touched yet. We also have thousands of high-resolution images of the lunar surface, extremely high resolution, good enough to show you the descent stages of all the Apollo missions, in some cases the flags, the rovers, even the tracks that the rover made during its excursions. So it's not really an unfamiliar place in that way. But put it in perspective, only 6 Apollo missions successfully landed on the moon. Only 12 men had that experience. And they were limited to more or less the equatorial areas of the moon. There weren't any landings in the north area or the south area or on the far side, which is significant because the far side of the moon is very different than the side of the moon that we see. But Apollo had its limitations, and this is what it could do. But if you ask yourself, if you took 6 vacations on Earth, more or less near the equator, and you went to 6 different places, would you really understand the Earth? Would you really know all of the different environments that the Earth has? Of course not. And so there's still an awful lot that we don't know about the moon and the lunar environment, how it was formed, how it affected the Earth. And so it actually is scientifically quite important to go back to the moon. There are a lot of questions that still need to be answered. And part of what we're trying to accomplish here is going to involve a base on the moon eventually. Because it's been discovered that at the south pole of the moon at least, there is frozen water, there's ice. And particularly some of these craters, now when you're in a polar area, the sun never rises very high. It just goes around in a big circle, okay? So a lot of these craters haven't seen sunlight for possibly billions of years. So every time a water molecule comes by, it's so cold, it just gets frozen into that area and then accumulates over that amount of time. So there are significant deposits at the bottoms of these craters. And that's really critical for a base, because if you have access to water, you have a lot of things, right? You have water to drink, sure, but you have oxygen to breathe. You have oxygen and hydrogen you can turn into rocket fuel. So there's a lot of things that you can do if you have access to a good supply of water, which is what these polar areas offer. And so eventually, as I mentioned, we're looking at having a lunar base that's continuously occupied. Just like the way the ISS is continuously occupied now, we want to do the same thing on the moon. The other reason to have a lunar base is everybody's looking towards Mars, right? And a lot of people will say, well, why do we have to stop at the moon? Can't we just start going to Mars and do all that? But there's still a lot of unknowns, okay? The base has to be totally recycling everything, okay? And it has to be really self-sufficient. There's a lot of techniques that we need to learn because the moon, with SLS, it's 4 days away. Mars, 6 to 9 months. And actually, if you consider the orbital positions of Mars and Earth, it could be 2.5 years. So when you go to Mars, you got to take care of anything that might happen if you're going to survive the trip and if you're going to survive on the surface. So this is going to be a really good training ground to get ready for that and learning a lot of the techniques that are going to be needed to make that sort of thing successful. On the other hand, the moon is worth a lot of money. There are a lot of natural resources that the moon has that could be quite useful and quite valuable to us here on Earth. Now, of course, you got solar power, you got water. That's great for the base, okay? So there's no problems with power, there's no problems with water. But the moon is also a rich source of helium-3. And if anybody ever develops a fusion reactor that actually makes more power than it consumes, and we switch over to that source of energy, they're going to need a lot more helium-3 because it's a really good fuel to use in fusion reactors. And there's been a bunch of it deposited by the solar wind into the soil or regolith of the moon. So that can be mined. Also, it has a lot of iron, titanium, aluminum, silicon, calcium, and magnesium. Okay, those are all useful things to have. It's also rich in rare earth elements. And that's really critical because we have a finite supply of that here on Earth, and it's getting pretty scarce. If you have a cell phone, if you have a computer, almost any kind of advanced digital device, that device is totally dependent on the availability of these rare earth elements. And so that's really probably the biggest thing. So once and if private industry gets involved, it's going to be very interesting days because the way I understand it, nobody owns the moon. So, like I said, interesting days. You can kind of take it from there. It also opens the opportunity for different technologies. Now, if you are going to export materials from the moon, one of the main ways you might do it is with a device like this. This is the spin launch test article that actually is out near Spaceport here in New Mexico, and they've actually been doing tests. And what they do is that circular structure is a vacuum inside, and they spin up their payload to a very, very high speed, and at exactly the right moment, they release it. It goes up through that tube, blasts through a membrane, and gets lofted up. And it gets lofted quite high. And so the idea here is you're using this energy to get it to a certain altitude, and then its engine fires and takes it the rest of the way into orbit. But imagine doing this on the moon, right? It's a vacuum. The whole thing could be an open structure. You're not going to deal with atmospheric heating and atmospheric drag. So in that type of an environment, this type of a system actually turns out to be very efficient. So it could be one of the ways that we actually get some of those materials from the lunar surface to Earth orbit where we can actually deal with it. Another technology that's been around for a really long time is something called a mass driver. Okay? So if you have a metallic magnetic container, and it's full of your material, you can be run on solar power. You see those big arrays over there. And there are a series of magnets down this track, and each magnet gives that payload a little bit of a push. And so as it goes down the track, it gets going faster and faster and faster to extremely high velocity at the very end, which is another way to get material off the lunar surface that doesn't require a rocket and the expense and the complication of doing that. These are relatively simple systems. So if we do get into mining the moon, this is probably the kind of thing that we're going to be doing it with. And as I mentioned before, the ultimate goal is actually Mars. And the establishment of a lunar base on the Martian surface and a permanent presence on the Martian surface. You know, SpaceX and Elon Musk has a lot to say about this. I think a famous quote from Elon is that, you know, he wants to die on Mars, just not on impact. So he's pretty serious about it, and that's really what's driving all of the development with SpaceX right now. So this is SLS is part of a very, very important stepping stone to eventually accomplishing this great goal, which actually could end up being an independent branch of humankind, with their own politics, their own rules, their own culture. And then once you get to the point where you have multiple generations who are born on Mars, they probably will never return to the Earth. Why would they want to? Any questions? I'm sure you may have some. Yes?
Why did they abandon the helicopter retrieval of the capsule and use the ship bay?
I think it's safer, it's simpler, and that's the way they recover the SpaceX Crew Dragon spacecraft now. So, yeah.
They don't need to get the crew out right away.
No.
For one thing, and the other thing, you know, obviously they used to helicopter the crew away, which is a dangerous evolution in itself.
Yes.
Bennett was in the Navy for 20 years and helicoptered numerous crew members off of the submarine. It is very dangerous. And so you eliminate that, and it's so simple to bring something into the well deck of one of the ships. So just bring them into the well deck, drain it, bring them out, because they used to have to crane the capsule up onto the ships as well. Yeah. This just is actually much simpler, and I don't know why we didn't do it in the past. I don't think we had the exact same capability with our amphibious style ships.
Yeah, I think that's right. And it's a very, very good system. They just leave the capsule powered up. The astronauts are sitting there, nicely warm and happy, and they don't really have to do a whole lot. Just open the door and walk out of the well deck. So it's a great system. Good way to do it. Yeah.
I heard that they were going to land on dry land, in fact, out here at Weiss Ends.
You're thinking about the Boeing capsule.
Starliner.
Yeah, Starliner.
Right.
And it's, yeah.
And it has landed twice out here. And,
yeah, twice.
Yeah.
And
crewed mission probably next year.
Yeah, hopefully, we'll see. Boeing can get their act together. That might happen.
Well, that's different than this capsule?
That's different.
Yeah.
Yeah.
I didn't realize there were two different.
There's actually 3 different human spaceflight capsules that are going to be in operation within the next 2 years.
Yeah,
so.
the Boeing capsule, Crew Dragon from SpaceX, and Orion. But Orion is the only one that's really designed for use in deep space.
Yeah.
The others are low Earth orbit, getting back and forth from the ISS, that kind of thing. So each one has different reasons for being and different design factors to it. Yeah.
So that first mission that comes out and moves around,
Right.
and comes around.
Round and around we go.
That's not me.
That's not manned. It's totally unmanned. Totally unmanned.
It's the second one which is loose.
Right, right. And the first crewed, that's Artemis 2, which would be the first crewed mission. It's not a landing mission. It's just taking the crew out, looping around the moon, and coming back. So again, just a test of you can think of it as being analogous almost to Apollo 8, right? I mean, Apollo 8 did orbit the moon, but it was really a complete exercise of the system, but with crew on board. So this is kind of similar, not quite as ambitious, it's a little bit safer.
So it's a vehicle test more than a go to the moon test?
It's both. But you're testing the vehicle, but now not only are you testing everything you tested in Artemis 1, but you're testing all of the crew support functions that it has, okay, and seeing how that works. So that's kind of a whole different set of tests that you really want to run. Yeah. Yes?
The last mission, our first mission, had to cancel because of a hydrogen leak.
The first mission wasn't canceled; it was just postponed. They weren't.
And postponed.
How many tries was it? 3 tries, I think, this year?
Yeah, 3 tries. Yeah.
3 times they rolled it out and tried to launch, and they couldn't. Hydrogen is tricky. They had the same problem during the space shuttle era. There are a number of space shuttle launches that were delayed because of hydrogen leaks during fueling. And the thing about hydrogen, it's a tiny, tiny, tiny little molecule, right? So it loves to leak. It will leak at any opportunity that you give it. And of course, when you mix hydrogen with air, now you've got an explosion on your hands. So not only does it like to leak, but it's very, very flammable. It can be quite dangerous that way. If you remember during a shuttle launch, remember those sparklers that would be firing under the engines before the engines would light? That was just to burn off any residual hydrogen that might have been down there before the main engines ignited. And so you got to be very careful with this stuff. It is not easy to handle at all. So it's not surprising that they did have some problems in that area. They had other problems too. But I'm feeling pretty good about this launch on the 13th because I think they've worked out most of the problems, and the problems they haven't worked out, I think they're at the point now where they understand them well enough that they can work through them in real time. But we'll see. Just tune in and see what happens. So, any other questions?
Yeah.
Yeah.
The timeline where it shows they're going to do this,
Yes.
and they're going to carry the fuel, I guess, with the hydrogen. They're going to carry what, full vessels of that and carry it up.
Oh, to Starship.
Yeah.
Yeah, when they use the Starship as a lander. The fuels will be different though, because Starship uses liquid methane and liquid oxygen. It doesn't use liquid hydrogen, so it's a little bit different. Not as difficult to deal with. Yeah. Yes.
Could they just land the Starship on the moon?
Well, that's an interesting question, and it's a question.
I mean, it lands on Earth, right?
Starship is an interesting vehicle because it can land on any available surface in the solar system, at least places that have surfaces. So not Jupiter or Saturn, but it can land in an atmospheric situation. It can land on the airless moon. It can land on Mars, which kind of has an atmosphere. So it kind of is a Swiss Army knife. It can do it all. And once it's fully fueled, it can reach places like the moons of Jupiter, if that's where you want to go. So I'm not sure how that's all going to play out. We'll just see.
Kind of contractual.
It is contractual, and of course, you saw the launch of the Falcon Heavy not too long ago, and SpaceX is very intertwined with NASA right now, and NASA facilities. As a matter of fact, SpaceX is building a Starship base at Kennedy, so they're going to be both in Texas and in Florida. So we'll see how it works out. I haven't even seen any bit of Starship lunar lander variant hardware, and I don't know that they're even bending metal on that. And I do know the first Starship that lands on the moon is going to be a stripped down version. It's only going to have what it needs to get out there and do the landing, and they're going to leave it there. So that's kind of the way SpaceX does things. If you looked at the evolution of Starship, all those crazy tests that they had during pandemic, right? The vehicle started off as almost boilerplate with engines. And then with every subsequent test, it got a little bit more sophisticated and a little bit more closer to what the final vehicle was going to be, and that's how they do it. And so the first lander is going to be very much like that too. So we'll just see how that.
And keep your eyes open because Starship should have a launch here in early December.
That's
of the full up,
right,
fully stacked
that's right.
version, the first launch of the fully stacked version.
And I think if you remember my talk about Starship, that booster, 33 engines. It's a lot of engines. But then I'm thinking about the recent Falcon Heavy launch, and that's 27 engines. Made me realize that going from 27 to 33 really isn't that much of a leap. So hopefully that'll work well. They still haven't done a test where they fire all 33 on the pad, just for a few seconds. And that'll have to happen before they actually try for the orbital flight. But yeah, I would say the orbital flight attempt looks like it's going to be before the end of the year, maybe. There's definitely a chance, and it'll all depend on how that engine test kind of goes, and of course a lot of other things. But it's an exciting vehicle.
When they do that polar orbit of the moon,
yeah,
is that to keep communication so they don't keep going behind the moon and can't communicate?
That might be part of the reason for it.
Because if they're that away, they got a clear shot.
But the way orbits work, if you want to put a a space station in low lunar orbit, let's say 60 miles, okay? It takes a lot more delta V to get out to that point and dock with that station. But if you're in a very elongated orbit, like that rectilinear or halo orbit, when you're way out here, far, far away from the moon, your velocity is quite low. And so the delta V requirements are less if you meet up with the station there and then ride it down to where it's close to the moon. And then at that point, you can leave in your lander and get to the surface. So there's a lot of reasons like that. And I'm sure there are others that I'm not aware of.
Why don't they have like little satellites so when they go behind the moon, they can...
They probably eventually will. Yeah.
They'll have to.
seems
They'll
like
have to. Yeah.
They'll have to,
They're
yeah.
still going dark when they go
That's
behind
right.
the moon. It's
Yeah,
like,
that's right. And that's one of the reasons during Apollo we never landed on the far side.
Yeah,
Because they didn't want to have that, not knowing what's going on. So,
That's when you go pilot.
yeah. I mean, they would have had the ability to relay because the command module was still in orbit. And so it would pass over the landing site once every orbit. So, they could communicate in that fashion. But they couldn't communicate in real time. And I don't think that the managers with Apollo were very comfortable with that idea. Because I'm sure some of the astronauts, some of the scientists particularly, were pushing to see, can we do that, right? So, and it would have been really interesting because that far side of the moon is quite different. Yes?
Why are they starting to use liquid hydrogen and methane instead of kerosene like they used to use?
Okay, you're talking about SpaceX? Because they use liquid methane and liquid oxygen. A couple of reasons for that. I think one of the main motivators for that is you can make methane on Mars. Okay, and you can take the atmosphere and you can actually so you can make the fuel, at least part of the fuel that you need. And if there's ice on Mars, which there is, then you can get the oxygen component. So by using liquid methane and liquid oxygen, those are, as far as Mars is concerned, those are in situ fuels. You can make those on the surface. And I think that was a large part of why they chose that fuel combination. Liquid kerosene, RP1, that's what the Saturn V used. It used RP1 and it used, again, liquid oxygen. But we're looking at engines that are going to be reused. And RP1 is very sooty. And so it tends to coke up the insides of the engines. It makes them hard to reuse. So that's really the reason you didn't want to use anything like RP1. The methane burns much, much cleaner. Because remember, that huge booster, right, for Starship is going to come back and land just like the present Starship boosters do. But with a little bit of a difference. It's going to be landing at the launch tower. SpaceX has these two giant arms, they call them chopsticks. And the idea is that the booster's going to come down, it's going to align itself, come down right beside the launch tower, and these two large metal arms are going to come in and actually catch it. So, we'll see. It's a great opportunity for really, really interesting viewing, I think, depending on how that goes. Either way, it's going to be pretty spectacular. But that's the way they plan on doing it. And because they're planning on launching these Starships with a very, very quick cadence. And the only way that they can do that is to minimize the amount of time it takes to land a booster, do the refurbishment that they need to do, and launch it again. So if it lands right at the tower, right, and they can just set it down, do what they need to do, fuel it up, and go again. So it allows you to do it very, very quickly, which is kind of the whole idea. All right, then. Well, thanks for coming in on this cold New Mexico morning, and I really appreciate it. And I'm going to take a moment here. Kathy's going to update you on things that are going to be happening around the museum.
Thank you, Tony. Good job.